Well, good morning once again, everyone. Welcome in. Welcome to our webinar. We're going to go ahead and get things started here this morning. My name is Bram Briscorn. I am one of your OpCert coordinators here with ADEQ, but today we will be discussing PFAS in Arizona. A little bit of housekeeping before we begin with our presenters. For all of you certified operators joining us today, PDHs are available. Make sure that you download the handouts. The agenda specifically is what you can use to submit your PDHs on your OpCert portal for renewal. For the duration of this webinar, webcams are disabled. Attendees are all on mute. But if you do have any questions during the length of this webinar, feel free to drop them in the questions drop-down menu on the GoToWebinar panel. We will have some time to address those questions and more at the end of the webinar. This webinar is being recorded. It will be posted on our ADEQ YouTube channel in the coming days. So if you would like to revisit it or share it around at any time, it will be available for you there as well. And in the event you're not seeing the handouts drop down, that should have the agenda. You should have copies of all of the PowerPoints, all the presentations that we'll be seeing today. I will also be emailing out a share file, which is just a digital file that will have copies of those presentations as well. Before we begin, just a couple notes for certified operators. Those of you who are certified operators joining us today, a couple reminders. Requesting that you're checking your portal accounts regularly. Don't wait for renewal, but check them periodically. Make sure you know your effective and expiration dates for all of your certifications so that you don't run into any last-minute problems. I also recommend, not a requirement, but I very much recommend uploading your PDHs as you obtain them. For example, right after this webinar, you can hop on your portal, you can download that agenda, you can submit these two PDHs, and you won't have to worry about it. It's just a little best practices there. Make sure that you're in your portal and you know how it works. One final note for certified operators, if you're ever in doubt, reach out to us. The OpCert program is happy to help. We have our email and our phone number there, as well as our website on the ADEQ page. You can find that email and phone number as well, and we will be happy to assist you with any questions that you do have. So without further ado, we will go ahead and get started. I'm going to pass the screen over to Gavin, who will be bringing us a discussion on the implications of PFAS regulations in Arizona. Gavin, feel free to unmute, and you should have screen control now.
Okay, good morning, everyone. Welcome to the PFAS webinar here. Can you all see my screen?
Looks good.
Okay, great. So my name is Gavin Walton. I'm a compliance assistance coordinator here at ADEQ, and I'm going to be discussing the PFAS rule today and its implications for drinking water systems in Arizona. Just to give you a quick outline, I'm going to go over PFAS as a contaminant, and then go talk about the sampling and monitoring that ADEQ is doing in the state for PFAS. And then the majority, obviously, of the presentation is going to be dedicated to the rule itself, the requirements, and how we implement it to have drinking water systems set their monitoring schedules. I'm assuming all of you know a little bit about PFAS, otherwise you wouldn't be here, but just to give you a brief background, these are a class of chemicals. They're synthetic chemicals that you find in various applications. They are basically made up of a chain of carbon atoms that have fluorine bonds and fluorine atoms on them. This is why they're called, excuse me, per and polyfluoroalkyl substances. And this bond is incredibly strong, which lends itself to its applications in waterproofing and nonstick cookware. You know, it has a lot of good applications, but also it persists in the environment for a very long time, and that's why they're called forever chemicals. Due to their persistence, they tend to bioaccumulate in organisms as well, in living tissue, and this poses some health risks, and this is why the EPA is concerned and why ADEQ is concerned about PFAS in our environment. So here's just an overview of kind of like the life cycle of PFAS in the environment. So we have it in our homes, it's in our furniture, it's in our apparel, our clothing. These end up in our waste stream, that ends up in our landfills, that eventually leach into wastewater treatment plants. And this discharge and runoff goes into our waters, our surface water and groundwater. You can see the firefighting foam there. That is just basically just gets washed off into stormwater. All this ends up in our water tables and our groundwater, which of course goes into our drinking water systems. And this is, the main concern and the main route of PFAS into our bodies. So, why should we care about PFAS, and why is it such a big deal? There are a lot of various health issues related to it. A lot of epidemiological studies have shown that that is linked to higher rates of cholesterol, changes in liver function. For pregnant women, there's going to be lower birth weights or premature birth, high blood pressure, and just a whole host of various health issues and poor health outcomes for people that are exposed to PFAS. And also, there is some research that shows that it is a carcinogen. It's been linked to kidney and various other cancers. So, overall, PFAS is an emerging contaminant. It is something that we really, as ADEQ, are trying to take a spearhead monitoring in Arizona because of its public health issues. So what are we doing in Arizona as far as monitoring and sampling? Well, for PFAS, we have to go all the way back to the UCMR rule. This was set by the EPA, promulgated in the 1990s. Essentially, it's asking drinking water systems to monitor for contaminants that are not yet regulated. Every 5 years, they set a new list of contaminants. It's roughly 30. And any water system that serves more than 10,000 people is required to test for these unregulated contaminants. The UCMR rule is, it helps the EPA to monitor unregulated contaminants and to judge whether they are of public health concern and if they should be regulated in the future. There are two iterations that we're concerned with here. It's UCMR 3 and UCMR 5. UCMR 3 had roughly 30 contaminants that included 6 of the PFAS compounds. And this is when we first started to see PFAS crop up in drinking water in Arizona. The testing period was between January 2013 and December of 2015. And we looked at water systems serving more than 10,000 people. And at that time, there were 82 water systems that had 6 detections of PFAS compounds. And these were regulated compounds. The currently regulated compounds of PFAS. And that, that water was being served to around 6 million people. So it's quite a lot. UCMR 5, on the other hand, is currently happening right now. It started in January of 2023 and it ends in December of next year. This one is requiring water systems that serve more than 3,300 people to partake in sampling. In the state of Arizona, that is going to be 150 water systems. In total, we have around 1,500. So it's only 10% of the total water systems in the state, but that represents around 7 million people being served drinking water. So it is around 90% of the population, excuse me, and it's a significant portion of the state. So that's why we're concerned with UCMR 5 and monitoring these water systems. So far, we've tested 98 systems. 31 of these have had detections for PFAS and 67 have shown non-detect. Moving on to the ADEQ, the targeted screening we started in 2018. This was prompted because of the UCMR 3 rule and because we saw PFAS at that time. The sampling took place for a few months in 2018 from January to April, and we found 12 new detections of PFAS. At that time, we were only looking for PFOA and PFOS because they do have a significant health risk. And now in our current phase from 2023 to the present, we are looking at smaller drinking water systems and doing a lot of sampling thanks to funding from the Water Infrastructure Finance Authority. We're basically just making sure that these drinking water systems are being monitored for PFAS. And I should point out that these are not being sampled or monitored under UCMR 5. So they are smaller drinking water systems, disadvantaged systems. We're just helping them to meet the initial monitoring requirements for the PFAS rule. So the two methods that we use for sample analysis from the EPA, these are the two only certified methods for compliance: method 537.1 version 2 and method 533. My method 533, as you can see on the list there, analyzes for more PFAS, but they're typically going to be short chain PFAS. 537.1 version 2 is going to look at longer chain PFAS. Of course, there is some lab overlap there. And I should point out that version 2 is the only accepted method. In the past, they had 537.1 modified version or version 1. Those are currently not accepted by the EPA or ADEQ for compliance purposes. This is just a brief overview of where we are at with our PFAS sampling in phase 2. As you can see, around 82% of systems are showing non-detect, which is great. Detections mean any sort of PFAS coming in above the trigger level, so that's all non-detect. 12% have PFAS that is above the MCL, and we're working with these systems to help them bring those levels down through treatment or mitigation. And 6% of systems in the state have PFAS that is above the trigger level but below the MCL. Here's just a great resource that we have on our website for PFAS. You can look at different drinking water systems in the state. You just follow that QR code there, click on any of those highlighted circles, and you can see the latest analytical results for that system. So now I'm going to get into the PFAS rule and what it means. It's the most exciting part of the presentation, I promise. So what is the PFAS rule exactly laying out for water systems to do? It's requiring them to, 1, conduct initial and ongoing compliance for 6 regulated PFAS compounds. It's also helping them to find solutions to reduce their PFAS levels if they have an MCL exceedance or if they violate the MCL level. And then lastly, it's requiring systems to inform the public of their regulated PFAS levels in the water, in their drinking water, as well as if there's a case of an MCL exceedance. And this is done through either a Tier 3 public notice or the Consumer Confidence Report. So here's the list of the actual 6 regulated PFAS, and this was finalized in April of this year. As you can see, we have PFOA and PFOS. They have an MCL that's lower. It's around 4 parts per trillion. And then PFHXS, what we call Gen X chemicals. It's a lot easier to say than HFPODA. PFNA, these are all set at 10 parts per trillion. And then down at the bottom, we have what they call the hazard index chemicals. So these are going to be any of these 3 from above, PFHXS, Gen X, or PFNA, as well as PFBS. And PFBS does not have an MCL, but with the hazard index chemicals, they have to be in combination with each other with of at least 2 of these chemicals or more. So if you have PFNA by itself, you're just going to look over to the MCL 10 parts per trillion here. If you have PFNA and Gen X, then you consider them as hazard index, and there's a whole formula that I'll talk about here in a little bit with regards to that. The MCL goal over here It essentially is just a non-enforceable health standard. PFOA and PFOS, they try to get it down to 0 for the goal. And this is based on the latest science that shows that there's really not any healthy level of exposure to these two PFAS compounds. In reality, it's very difficult to set it at 0, so they set it as low as they could, which was 4 parts per trillion. One important note is that for compliance purposes and when you're, trying to figure out your running annual average, for PFOA and PFOS, the EPA is requiring that you round 2 significant figures. So in this example, we have a result of 4.02. That's going to round down to 4.0, and then that would be considered to be in compliance. 4.05 is going to round up to 4.1, so that would be an MCL exceedance in that case. PFNA, PFH excess, and the GenX chemicals all round to 1 significant figure. So in this example, 14.9 is going to round down to 10, and then 15.0 rounds up to 20. It's quite a wide range. Not quite sure why it's set like that, but that's how the EPA wants us to round these numbers. The hazard index chemicals are going to round to 1 significant figure, and then the same goes. 1.49 rounds down to 1, and 1.5 rounds up to 2, and that's an exceedance. Okay, so the hazard index chemicals, there's a formula for this. Basically, you take the concentration in parts per trillion of at least 2 of these, and then the denominator down there is the health-based water concentration. So you divide by the denominator, add all these up, and you get what's called the hazard index value. So in this example, we have a system that is on a quarterly monitoring schedule for hazard index chemicals. Let's walk you through example 1. This is 1 quarter. GenX, we had non-detect. PFBS, 200 parts per trillion. PFNA came in at 4 parts per trillion, and PFHXS, 4 parts per trillion as well. Run it through the formula, and it spits out 0.9. For quarters 2, 3, and 4, we get 3, 1, and 2. You add all of these up together in your running annual average, and you get 1.725. Remember, we have to round to 1 significant figure. That's going to round up to 2, and that is a MCL exceedance for hazard index PFAS. Another important note is the trigger level that has been set by the EPA. Trigger levels are typically half of the MCL. So as you can see here, 2, 2, 5, 5, 5, and 0.5 for all the PFAS in the hazard index. In determining compliance, anything below those trigger levels is going to be considered as a non-detect. We also have the PQL, which is the practical quantitation level, and this is related to essentially like the minimum detection level in laboratory analysis. The only time this really comes into play is when we are determining compliance with the MCL. So during initial monitoring, excuse me, the PQL is not going to be of concern during compliance, and further on, I'll talk about that later, but essentially anything below the PQL is going to be considered as 0 in the RA calculation for compliance. So here's the time frame for water systems. So it was promulgated in 2024, April 26. So 3 years later, we need all water systems to meet initial monitoring requirements. 3 years following that point, so from 2027 to 2029, the results of all initial monitoring should be included in your CCRs, in your water quality reports to your customers. Regular monitoring for compliance must begin. This is after April 26, 2027, and the results of all compliance monitoring must be included in your CCRs. If you miss testing and monitoring for PFAS, you need to submit a public notice, a tier 3 public notice, and this is when monitoring and testing violations begin. Starting in 2029, all systems must comply with the MCLs, and the public notice for any MCL violation begins at this time. So here's some other monitoring requirements to take note of. Systems must take all their samples at the EPDS during your normal operating conditions. That's important. It has to be in the EPDS. No other entry point, no other sampling point is allowed. If the system draws water from more than one source and the sources are combined before distribution, the system must then sample at an EPDS during periods of representative operating conditions. Consecutive system interconnections are not considered as an entry point. So if you only get your water from a consecutive connection, then you're not subject to the PFAS rule. Lastly, transient non-community water systems are not required to comply with this rule. So for the initial monitoring requirements, so up until that point, 2027, April 26th, we need to set schedules for water systems based on the type of source water they have. So the EPA is requiring that all surface water systems monitor 4 consecutive quarters within a 12-month period. They call them quarters, but basically we need samples to be taken 2 to 4 months apart, but it has to be within 1 calendar year. The same is going to go for groundwater systems serving more than 10,000 people. They're also on that 4 consecutive quarter schedule. And then groundwater systems serving less than 10,000 people are going to be on a biennial schedule, so 2 samples within a 12-month period, taken 5 to 7 months apart. It's important to note that if a system is using both groundwater and surface water, then they are going to be subject to that surface water monitoring schedule. So to help fulfill that initial monitoring requirement, we are allowing, and the EPA is allowing, systems to use previously acquired data. The caveat is that there's some requirements that we need to be met. The data needs to be analyzed using only those 2 methods I talked about earlier, method 533 or 537.1 version 2. And the data has to have been collected on or after January 1st of 2019. And otherwise has to meet those requirements I just talked about with the 2 to 4 months apart for quarterly schedules, or 5 to 7 months apart for a biennial schedule. If it meets all of those, then it's acceptable as previously acquired data. If a system has multiple years of data, the most recent data needs to be used. Data has to be reported to a level no greater than the MCLs. So if the system wants to use supplemental data for reduced monitoring, it has to be reported down to the trigger level. And data collected on or after June 25th, 2024 must be reported down to all rule trigger levels. So for that supplemental data, for surface water systems and groundwater systems serving more than 10,000 people, they need to collect in a calendar year 1 sample in each quarter that was not represented. I'll get to that in a little bit. For groundwater systems serving less than 10,000 people, they need to collect 1 sample in the month that was not represented, 5 to 7 months apart from that sample they collected. So here's just a brief example of how a groundwater system that serves more than 10,000 people can use previously acquired data under UCMR 5. So as you can see, they have 2 samples that were collected under UCMR 5 in 2023 and 2024. They have quarter 3 and quarter 1 taken care of. So within 1 calendar year in 2025, they need to collect 2 more samples. Basically, they just need to fill in those 2 quarters 4 and quarter 2, and that will fulfill their initial monitoring requirements. So to go from initial monitoring to ongoing compliance monitoring, we have 3 different schedules for your ongoing compliance monitoring. We have quarterly, which is the default schedule, annual, and then triennial, which is reduced monitoring. 2 important points to note here is that when we're trying to determine compliance schedules for a system, we are going to take every individual sampling result for all the regulated PFAS and evaluate that. We're not looking at the running annual average, and we're going to compare that to either the trigger level or the MCL and determine the schedule that way. Once that schedule is set and determined, the compliance with the MCL is determined using the RAA, running annual average, and any result below the PQL is going to be considered as 0. So here's a breakdown of the different schedules and the conditions that systems need to meet to be placed onto each schedule. So like I said, quarterly is your default schedule. To get here, essentially, if you have any regulated PFAS concentration that is at or above the trigger level during initial monitoring, you'll be placed on the quarterly schedule. A system that is on triennial monitoring that has a result above the trigger level will be placed on the quarterly monitoring, and a system that is on annual monitoring that has a result above the MCL is going to be placed on the quarterly monitoring. So essentially, it's just the starting point for all compliance monitoring. Annual schedules are set as such that you have to be on quarterly to begin with, and then after 4 consecutive quarterly samples during that compliance monitoring period, the samples have to show PFAS levels that are reliably, consistently below the MCLs. And once you've met that, you can move on to annual sampling and annual monitoring. It's important to note that if you're on an annual monitoring schedule, the sample has to be collected within the quarter that yield the highest analytical results during the most recent round of that quarterly sampling. Lastly, triennial monitoring. This is it's kind of like the gold standard for monitoring schedules. To get here, you have to show during initial monitoring that all of your PFAS results were below the trigger level. So that's showing that you're serving healthy water. There is no risk of PFAS. It's below all the trigger levels, and you can jump from initial monitoring straight to triennial monitoring. Or if you're on annual monitoring, you have to show that you have 3 consecutive years of results that are below the trigger level. Then you can come off of annual monitoring and move to triennial monitoring. Here's just a kind of a helpful graphic for that. So we have our initial monitoring. If you have 4 quarters of data that is below the trigger levels, you can basically jump straight to triennial monitoring. If you have any result above the trigger level or MCL, you're going to go to quarterly monitoring. And then the goal is to kind of work your way over to annual and hopefully eventually reduce triennial monitoring. Like I said, it's the gold standard. If at any point, like on annual monitoring, if you're on annual monitoring and you have a sample above the MCL, it's going to put you back on the quarterly. If you're on reduced triennial monitoring and you have a sample hit above the trigger level, that's going to send you all the way back to quarterly monitoring, and you can start all over again. This is just kind of the flow of how it works, but hopefully that lays it out in a clear, concise way for you. Here's just a little bit of practice. So we have a groundwater system that's serving 12,000 people with 3 EPDS. We're trying to determine both their initial monitoring schedule as well as their compliance monitoring schedule. So we have two quarters of previously acquired data here. We already know that they have a population of over 10,000 people, so that should kind of give us a clue to their initial monitoring schedule. Looking at those MCL levels and trigger levels, we can see that we have, a few exceedances here, especially with PFOS, PFNA. There's a couple trigger level exceedances, and then PFHXS and hazard index, we have MCL exceedances. So what do we think the initial monitoring schedule should be for this system? Well, we know that they serve more than 10,000 people, and they have hits above the trigger level, so that's automatically going to put them onto quarterly monitoring. So they have 2 quarters. They need 2 more quarters. So did they meet their initial monitoring requirements? The answer is no. If not, what additional samples need to be taken? So, like I said, they need 2 more to fill those 2 quarters. It's going to be either in, between February and April, or August and October, and August and October of 1 full calendar year. And coming off of an initial monitoring and moving on to their compliance monitoring schedule, they're going to be put onto a quarterly compliance schedule because of those MCL exceedances and trigger level hits. And that'll do it for me. Hope you all enjoyed the presentation, and hopefully I cleared up some questions that you had. If you have any at the end, we're going to have around 15 minutes of Q&A time, and I'll be happy to answer any questions you have. With that, I want to pass it off to Hannah and Austin to talk about the ADEQ PFAS sampling project. Thank you all very much.
Thank you very much, Gavin. I will pass the controls, as Gavin said, over to Hannah and Austin. I do see there were a couple questions in the questions drop down, but I see Sarah was able to answer those. So thank you, Sarah. Feel free to keep adding questions to that questions box, but any we don't get to during the presentations, as Gavin said, we will address at the end. We'll have some time for Q&A. Austin, I should have sent screen control to you so you and Hannah can unmute and take it away.
All right, good morning, everyone. I'm Hannah Houston, and presenting with me today is Austin Pancook. We're environmental technicians here with ADEQ, and we're just gonna touch on some basic information on PFAS, and then we're gonna review best practices for sampling techniques and some guidelines to follow when out sampling. So since December of 2022, our ADEQ PFAS sampling team, which does include Austin and myself, have been collaborating with hundreds of public water system owners and operators and contractors to assess the impacts of PFAS on Arizona's drinking water. And to date, we have sampled over 700 water systems statewide. So PFAS, or per and polyfluoroalkyl substances, as Gavin mentioned, are a class of synthetic chemicals that were developed in the 1940s. These chemicals are widely used in consumer and industrial products to resist heat, oil, stains, grease, and water. So they're very helpful in our common day lives. We encounter them quite often. Some of these examples are food wrappers from fast food restaurants, coated packaging. We've got water and stain resistant coatings that are used for textiles and furniture, pesticides, and also in materials for building and semiconductor industries. So PFAS, as you may have heard, are referred to as forever chemicals, and this is just due to their persistence in the environment and also their resistance to natural degradation. So we're going to touch again on how PFAS is entering our water and why it's important to sample for it. So as we can see here, PFAS can reach our water systems through various pathways. For instance, PFAS containing products in our landfills can leach into soil and groundwater, and emissions from manufacturing facilities can release PFAS into the air, which later can settle back on the surface through rain. And then additionally, we've got PFAS found in areas where there's been firefighting foam usage. So this would be training facilities, military bases, and airports. And this would be impacting both the soil and the surface water in those areas. PFAS are also present in biosolids, and this can subsequently leach into nearby water sources when used in things like fertilizer. And then finally, we do see PFAS from upstream sources that can be transported into the area through rivers and streams. So PFAS sampling does differ significantly from standard water quality sampling, and this is due substantially to the higher analytical costs and heightened risk of contamination. So PFAS analyses can be 2,000 to 6,000% more expensive than typical tests, and these costs can also be influenced by additional quality control measures such as field blanks. Detections are analyzed in parts per trillion, or PPT, and to put that into perspective, it's roughly equivalent to a single drop of ink in 20 Olympic-sized swimming pools. So this does amplify the potential for environmental and sampler contamination, given the ubiquity of PFAS in our everyday products. So here we have this graph again showing all the PFAS in each of the methods. So there's going to be 2 analytical methods that the EPA has approved for testing PFAS in drinking water. Method 537.1 version 2 and method 533. And both assess the 6 EPA regulated compounds, PFOA, PFOS, PFNA, PFHXS, and Gen X chemicals. In addition, in total, these methods cover the 29 PFAS compounds, with 14 of those compounds being tested in both of those methods. So some of the key differences between those 2 methods would be the hold times and the preservatives. Method 537.1 version 2 requires Trisma preservative and has a hold time of 14 days, while method 533 uses ammonium acetate and has a hold time of 28 days. And both of these methods do require a field blank with the corresponding preservative to ensure the data integrity, but it's not mandatory to use both of these methods when sampling, but if you do, it does provide a QA/QC, and it could reduce the need for possible resampling or the risk of unreliable data. So now I'm going to turn it over to Austin. He's going to go more in depth on the sampling techniques and guidelines to follow.
All right, thank you, Hannah. PFAS sampling is something that not many have experience doing. We're glad to have the opportunity to share our experience here with PFAS sampling and talk about the nuances compared to other types of sampling. This slide provides an overview of things to consider when collecting a PFAS sample. We'll go into further detail on each of these points in the next few slides. But when you're in the field collecting PFAS samples, just ensure you are adhering to the standard operating procedures, trainings, and checklists provided in this presentation. Our SOPs for each method can be provided upon request. Just reach out via email and we can share them with you. We use sample bottles provided by a third-party lab. As you can see, these kits come with a field blank, 2 grab sample bottles, a set of nitrile gloves, and a bag for storage and transportation. A complete and accurate chain of custody must be submitted for every sample delivered to the lab. So since we're talking about parts per trillion with PFAS analysis, cross-contamination is a big concern. We just want to ensure we are not bringing anything into the field that could impact the sample. This is just a list of prohibited and acceptable items to bring with you in the field when collecting PFAS samples. It's pulled directly from our standard operating procedures and should be consulted before going into the field, just to ensure you are not bringing a potential contaminant to the sample site. We'll go into more detail on field equipment, field clothing, and PPE in the next few slides. But just moving down the list to sample containers. Sample containers will not be an issue if you use the kits provided by our third-party lab. DPE or glass containers and Teflon line caps are prohibited, but HDPE or polypropylene containers and unlined polypropylene caps are acceptable. For rain events, avoid using any waterproof or water-resistant materials. In the case you have a gazebo to protect you from the rain, Only touch or move it prior to and following sampling activities. For equipment decontamination, avoid using any disinfectants, but if necessary, Alkanox or Liquinox and potable water from a municipal drinking water supply are acceptable, but just try to avoid using water from an on-site well. And for food and drink, avoid bringing anything to the sample site, with the exception of bottled water or hydration fluids, but just make sure you only consume these in the staging area. So you want to avoid using any products as part of your personal cleaning or showering routine on the morning of sampling. This includes cosmetics, moisturizers, shampoo, conditioner, deodorant. Sunscreens and insect repellent are acceptable, provided you use the brands listed here, such as Alba Organics Natural Sunscreen, Yes to Cucumbers, Aubrey Organics, Jason Natural Sunblock, or a Kiss My Face. Again, avoid bringing any food, drink, and fast food wrappers or containers to the sampling site, with the exception of water or hydration fluids that can be consumed in the staging areas. So you want to wear well-laundered clothing that has not been washed with fabric softener. Avoid clothing with materials like Gore-Tex, new cotton, or synthetic water-resistant or waterproof clothing. Boots and wet weather gear can be made with polyurethane and PVC, but waterproof or water-resistant materials are prohibited. You'll want to avoid using plastic clipboards or binders. We typically use aluminum clipboards with non-waterproof paper. You want to use traditional ballpoint pens or pencils. Sharpies are prohibited at the sample site, but can be used in the staging area if necessary. Just make sure you don't use these Sharpies on the sample bottles. And do not use waterproof or treated paper or field books, plastic clipboards, Post-its, or other adhesive paper products. Use Ziploc brand bags for sample storage and shipping if necessary. Our kits from our third-party lab include a bag for storage and transportation, and only use wet ice for sample preservation. Try to avoid using the chemical ice packs like blue ice. So these are the methods that the EPA has approved for PFAS sampling in drinking water. Method 533 uses ammonium acetate as a preservative, and method 537.1 uses Trisma as a preservative. These kits should be stored in a cool, dry area and last a year after their manufacture date. Make sure each bottle has a preservative by shaking it. All bottles, with the exception of the pre-filled field blank bottle, should have a preservative. If any bottles do not have preservatives, contact your third-party lab to get new bottles. And from left to right, you can see we have the field blank bottle containing the PFAS-free water, an empty field blank bottle, and then the two grab sample bottles. So as you can see, both the grab sample bottles and the field blank are labeled with the PWS number, the EPDS number, as well as the method number. There's a space below the PWS number and the EPDS number for the date and time. The date and time will be completed at the sample site. And as always, just ensure all information on your bottles matches exactly to what's on the chain of custody. And this is the chain of custody form that we use. We found it useful to fill out as much information on the chain as possible prior to sampling. Make sure to fill out all appropriate client information that pertains to your system. And then moving from left to right, you'll want to add your PWS number. Leave the sample date and time blank, since you will fill this out at the sample site, and add your EPDS number to the facility ID column. In the number of containers column, write a 2 to correspond with the 2 grab samples and a 1 to correspond with the 1 field blank. Under requested analysis, record the method you are using and your method field blank. Record an X to correlate the number of containers to the requested analysis, and make sure you write hold under the lab number column in the row of your field blank. Field blanks only need to be analyzed when grab samples have a detection. Adding holds to the field blanks will prevent unnecessary analysis costs. And finally, make sure the relinquished and samples received by sections are completed whenever samples are being transferred into someone else's possession. Next, we'll talk about the sample location. The EPA requires these samples to be collected at the EPDS, or the entry point to the distribution system. Entry point or EPDSs can look very different as seen in these photos. If your system does not have a tag, we'll discuss how to find the EPDS in the next slide. So if you're unsure where your EPDS is, just think about the flow of your system. Identify where your facilities are, like your well, your storage, or your treatment. The EPDS will be the last sample tap after these facilities, but before the distribution system or before water is piped into the building. Sampling at the EPDS will ensure you are analyzing finished water, which will show the best representation of the water your customers are using. So once you have found the EPDS, begin to flush for at least 5 minutes. One important lesson we have learned is the importance of flushing and ensuring there's little to no turbidity in the water. Turbidity in the sample can impact the equipment the lab uses to analyze the samples. So if you notice the water is cloudy or dark in color, just continue to flush until the water is clear. If you fill a sample bottle and notice sediment sinking to the bottom, make sure you discard that sample bottle and get a new bottle and then collect a new sample. Again, you do not want to wash out the preservative in these bottles, so the sample cannot be just dumped out and refilled. It is better to take the time to collect a quality sample. Failure to do so could result in clogging lab instrumentation and possible rejection of the sample. And not only would this cause issues for the lab, but it would also require you to spend more time and money resampling. So field blanks need to be taken for each method at every EPDS sample. As discussed previously, field blanks will be analyzed if the grab samples show a detection of PFAS. But like I mentioned before, if you write hold on the chain of custody, the lab will not run those samples if there is no detection. The pre-filled field blank bottle contains lab-tested PFAS-free water. If the field blank is analyzed and comes back with a detection, it indicates there was some type of contamination at the sample site. Field blanks provide quality control and are required when sampling for PFAS. So to take the field blank sample, just pour the water from the full field blank into the empty field blank bottle as pictured on the right here. Ensure you're wearing gloves and the inside of the field blank bottle cap and the cap are not touched. It is important to note when you're collecting the field blank sample, make sure you are near the EPDS. So if the EPDS is in a building, just make sure you collect the field blank in that same building. And moving on to sampling technique, you thoroughly wash, rinse, and dry your hands before collecting the sample. We recognize, there may not always be an opportunity to wash your hands right before sampling. So in cases like this, just wash your hands wherever you can and try to avoid touching anything that could potentially contaminate your sample until sample collection is complete. Then you want to flush the tap at the sample location fully open for at least 5 minutes. Then put on a clean pair of nitrile gloves. Remember, a new set of gloves must be worn per method sample, but that's only if you're sampling for both method 533 and 537.1. Record the date and time on the bottle and the COC. Then remove the sample bottle cap. Remember, the bottle contains preservative, so don't rinse the bottle or touch the preservative or the inside of the bottle. Do not let anything touch the inside of the cap or the rim. Next, you'll want to collect the field blank sample. Again, you want to be close to the EPDS to get an accurate representation of what the surrounding environment is at the sample location. If the EPDS is in a building, make sure you are collecting the field blank in that same building. Next, you'll want to fill the sample container. It is important not to overfill the bottle, which could wash out the preservative. To prevent this, you want the flow of the water to be no more than the width of a pencil. Also, do not let the container lip touch the sample tap. As you can see here in the photo to the right, the sampler has a pencil-thin flow rate and is holding the bottle close enough to the sample tap so there's no backsplash, but far enough away so the bottle lip does not touch the tap. Then once the sample is collected, gently agitate the bottle after the cap is firmly secured. And as soon as you have completed your sample collection, place the samples either in a Ziploc bag or the lab provided bag and put them on ice. It's important to start cooling these samples as soon as possible. Samples need to be cooled to 4 degrees Celsius, plus or minus 2 degrees, by the time they reach the lab. Also ensure you have a temperature blank in the cooler. In our experience, if you collect a sample and deliver it to the lab within 2 hours of collection, the samples do not have to be at temperature, but still need to be on ice. This is the only case where delivering samples to the lab over temperature is acceptable. Also note that samples delivered frozen are not acceptable. In our experience, the lab requires us to submit samples within 48 hours of collection, and this is just due to the hold times of method 533 and 537.1, which is 28 days and 14 days respectively. The lab needs as much time as possible to process and analyze these samples. So again, make sure you have your chain of custody forms with you and that they match all information on the sample bottles. If you have any questions regarding hold times or sample receiving, just contact your third-party lab. So this concludes our presentation on the nuances of PFAS sampling. If you would like to learn more about PFAS, EPA regulations, and what ADEQ has done to understand the scope of PFAS impacts in Arizona, just go ahead and scan that QR code on the screen. And thank you for your time.
Awesome. Thank you, Austin. Thank you, Hannah. Thank you for the presentation. As a reminder, certified operators, download the agenda. That's how you'll get your PDHs in your portal. But everyone else, feel free to download the agenda as well. We do have email contacts for all of our presenters today if you would like to follow up with any questions that you don't have right now at the moment. We still have the questions drop-down box there. Feel free to keep adding your questions there. I will pass the screen over now to Yasmina. We have one last presentation this morning looking at PFAS decision trees. So Yasmina, feel free to unmute. You should have control of the screen now. Perfect, that looks good. If you are talking, Yasmina, we can't hear you just yet. I see you are unmuted. Still no audio just yet. You might want to try hopping off and coming back in, or making sure that there's no other programs using your microphone at the moment elsewhere.
We do have a couple of questions that we can answer while we're waiting for Yasmina.
Yeah, perfect.
Okay.
That will work. There's a question here regarding the tape between pipes for Austin and Hannah, if we should be concerned about the tape between pipes.
You know, Teflon tape has shown to, contain PFAS, but in our experience, we've seen Teflon tape on the sample tap, and some results do come back non-detect still. So it's it's something we're aware of and we make a note of, but it doesn't seem to have that big of an effect on the result of the sample.
Oh, I'm back. So can you tell me if you can hear me now?
Yes, Yasmina, we can hear you now.
Oh, perfect. Okay, let me show
Awesome.
here my screen again.
And thank you, Austin. We will have some more time for questions at the end, but I will pass it officially over to Yasmina. Thanks, Yasmina.
Mm-hmm. Okay, perfect. So my name is Yasmina Markovsky, and I'm senior engineer with the drinking water section. Today I will talk about decision trees, which is a tool whose purpose is to help you choose between non-treatment and different treatment alternatives when it comes to mitigation of PFAS in your specific system. So I will be talking about why and how this tool was created, Then I will cover like inputs that you need in order to run this tool, and then how you analyze with the end goal in mind, and basically cover both non-treatment, treatment, but also simultaneous compliance with this tool. I will eventually summarize key takeaways from decision trees, but also talk about current and announced future ADQ support activities around the PFAS. So let's get started. First, why and how tool was created. I always like to start with problem identification, because where you have a problem, there is a need, and with need identified, you actually know what has to be done. So let's start with the permitting goals. If you have a PFAS project, that means that you are faced with complexity of PFAS contamination, that you have challenging treatment goals, and you have existing knowledge gaps. So on the other side, you start there, but there is a minimum design criteria which you have to satisfy, which means that you have to understand PFAS contamination and background water quality. You have to test performance of selected technology and operational parameters, and then you have to predict the impact of treated water quality on existing water infrastructure elements. And eventually, you have to have idea how you're going to manage residuals in line with the specific regulations. So this all is important, because all of this is needed to bring systems in long-term and simultaneous compliance, because what we all want is some kind of resilient solution. So if you go step deeper now, you will find that we have 6 permitting steps, and they're defined in this order. So first, you have to do sampling and analysis of water quality parameters. And the purpose of this first step is really to determine PFAS speciation and interferences, but also to go beyond that and to understand all the variations that you may have in your system. After you're done with the step 1, you should go and do preliminary design. Preliminary design means that you are supposed to select technology type that is most suitable for systems need. And when we say systems need, that means, you have your goal, but you also have specific technical, managerial, and financial capacity. When you are done with step 2, you go on step 3 and you do technology evaluation. And the purpose of this is to select optimal media and operational parameters. After all these 3 steps, you go on step 4, which is approval to construct. So that's actually the first time when you submit this ATC application to ADQ, and the point of this step is to get approval to permit the final design and start your installation. After that, step 5 is to basically do the startup. And with this step, you are supposed to confirm treatment suitability in regards to approved design. Finally, step number 6 is approval of construction, so-called AOC, and that's another step when you come to ADQ, and you need this approval in order to start serving PFAS treated water. And that all sounds great and straightforward, but when you look at the applications, you realize that the majority of projects actually have deficiencies in the first 3 steps. So these first 3 steps, they happen before you come to ADQ, but it's actually, they're needed in order to come to ADQ and to apply for that approval to construct. So when it comes to available support and program specifics, specific programs available for PFAS, we have sampling on one side, and that means UCMR5, and also in Arizona, we have state sampling. But on the other side, we also have funds for mitigation. So this is what is available. But the question is this enough for implementation? How to bridge these two available programs and support, and at the same time avoid mistakes in 3 steps that I showed in the previous slide. In other words, like when you get PFAS exceedance, what do you do next in order to get funds and start building your mitigation without deficiencies? Well, this is where the gap is. And simple manifestation of this gap is common question that we hear from public water systems. Basically, when they see PFAS exceedances, they come to us and say, okay, now what? So this issue exists regardless of system size. In Arizona, we have about 12% of public water system, or specifically 115, regulated by PFAS rule that will need some kind of mitigation. Of those 115, 90, or basically large majority, are small systems, and they serve less than 3,300 people. And this is where this gap becomes even bigger. And it's because these small systems, they have a limited TMF capacity. And although ADQ offers technical assistance, after all, it's really public water systems decision what is going to be done. So systems have to commit to that decision. So in other words, I mean, smaller the system, bigger the PFAS issue is. And that's why we actually did this guidance to help closing this huge gap. And this is the approach we took. So it's very important to define the purpose, whatever you do. In this case, we said we are doing this guidance in order to assist public water utilities. We want to assist them in making informed decisions about most suitable mitigation strategy. After the purpose, the question was, who is our audience? So this can be very wide, and I have to tell you, like, whatever we say, it will always be some other side saying, well, why you didn't direct this towards us? But in this case, we said we are talking to engineers who will assist utilities decision makers. And this is very important because for all of these projects, you have to have engineer, and eventually the engineer is the one who is submitting these projects for approval. And I just have to stress out here, you know, we have different level engineers, and that's all fine, but PFAS is very complex topic. So if you are looking for engineer, you really want to look for someone who has previous experience, not necessarily in the PFAS, but in water treatment design, because that's what you are looking for here. And that's how we targeted this document to those type of engineers. Third question was, you know, how we are going to like structure this document, in what form it's going to be. Our decision was to do step-by-step guidance, and basically to provide information what has to be collected, what screening test has to be performed, and then how you select alternative through use of decision trees. Finally, it was very important to define when this document should be used. And our goal here is to use this document in the very early planning stages. That means when PFAS exceedances are detected, and basically utilities are starting to consider compliance options and conceptual design. So to do something like this, you need a team. But now when this document is published, I can confirm that yes, it takes a village basically. But that's the key point and value of this type of document. It's not made in vacuum. So stakeholders were involved from the very beginning. So when I say stakeholders, that means that we had multiple people from state government, then federal government, specifically EPA or the office help us here. Then we had non-profit organizations, we had leading media manufacturers and consulting firms. And, you know, you can imagine like, you know, how these people are competitive, but it was very important to bring them all together and to find something that we all agree to. So let's now go into specifics and talk about what information you need in order to run this tool. So to do any kind of design, you need information and data. There is nothing new about it. You can organize this and say you need to collect knowns and screen unknowns. So when it comes to PFAS, what are knowns? So you basically have to understand your system and what do you want to achieve. So that basically means define your treatment goals. Define your non-treatment goals, because maybe you have more than the PFAS in your system, and maybe you want to treat more than the PFAS. So the approach will be very different. Think about your water demands. Like, it's not only like, what do you need today? Maybe you are planning future growth. Maybe your demand varies throughout the season. So it's very important to define worst case scenario. And then when you're talking about demand, you also have to think about your water supply. What do you have? What you don't have? Then what's your footprint? Like, how much space you have? What kind of equipment you can put there? Labor commitment. What level of operator you have? What can you afford? Then are you ready to lose some water? You will have some waste streams. You have to be very specific. How much can you afford to lose? Then corrosion potential. So you already have a system, but you're going to do some change here. So if you already have some corrosion issues, this is kind of a red flag. So think what you now have, because after the change, this can be magnified. And then eventually your residual management. So you will have a few waste streams. So it's going to be probably solid waste stream if you go with adsorption, but there are also some other streams like liquid streams in terms of at least initial backwashing of your media. So that's kind of like when I say collect knowns, like understand your system. But then there is also other side of the story that says screen unknowns. And here, what it means is you have to know what to sample, where to sample, and how often to sample. So I provided here a list of 3 groups of analytes that ADQ recommends to be done for each wellhead that has PFAS exceedances. And this is what Arizona State's sampling program also includes. So when we have a wells with the PFAS and then we go and do interference sampling, this is what we do. So eventually someone may say, why all this? You know, it's too much. Well, I would say, you know, like it's because as G.I. Joe says, now you know, and knowing is half the battle. You really want to know what you are dealing with before you commit to anything, and that's the key point here. So let's now talk about analysis. So how to analyze with end goal in mind. I know that with this line, I'm starting to sound like a project manager, but I found it very appropriate in this case. And here is why. End goal is very straightforward. And that's because we all want the same. We want to mitigate PFAS in easiest way. But, you know, how to be more specific about that easiest way? Well, we can say in a smart way. And that means you want to do it. You want to get your solution in specific, measurable, achievable, realistic, and timely manner. So that's why we say the goal is same for everyone, but circumstances vary and they dictate approach. And that approach can be through non-treatment or treatment options. And this is how it works. So your starting point always should be non-treatment. And that's because this is usually best shot for all systems, and especially those small and disadvantaged. I don't expect you to see all the details now, but it's very important to understand that these details are your solutions for specific situations. So when you go and download this document, take a look, don't skip things. It's very important to read all of this. But in a nutshell, non-treatment starts with asking you questions about other existing sources. And this is because you may have options to switching or to blending. And if this doesn't work, you should think about developing new or rehabilitating existing sources. And here you have three options. So first, you should start with the option that says connecting to nearby system. And this is something that, you know, it's usually opposed by systems, and it's probably because of water rights. But we had few successes so far, and I just want to share that, you know, like water rights are one thing, but eventually when you put everything on the paper, when you consider what you have to do, like, are you going to do the treatment yourself, or if you have potential to connect to nearby system, are you going to do that? It's really like that techno-economic analysis. It takes a lot to run treatment yourself. And then when you put that, you know, like what it takes, but also how much it costs, I have to tell you that systems are happy eventually to connect with that nearby system if it's available. Unfortunately, that's not the option that is available for everybody. So if you are looking for new source, basically that means that you will be drilling a new well. And then if it comes to that, it's important to understand that you have to try to understand source of your contamination, because the last thing that you want is to drill a new well and have that well again contaminated. So if you are thinking about drilling a new well, then you probably need to do a hydrogeologic study. Then eventually, third option here is to rehabilitate or modify your source. And that really means you want to understand where your contamination is coming from, and you want to isolate that area. There are a few options here. So you can think about video recording your casing, which is great, but it's not really directing directly providing solution. Then zonal sampling is something that gives more information, but again, doesn't have to be conclusive all the time. The third technique is dye tracing, and that's something that we are doing a lot in the last few months. But technique itself is very promising, but there are also a lot of issues here, especially if you have very small producer. If you're having a well, let's say with 20 GPM, you really have to think about, you know, like this equipment, like and everything. So it can be so small, and these wells can be so old that even the equipment can get stuck, things break. So the idea itself is great, it's very promising, but it doesn't mean that will bring you solutions that you are looking for. So all non-treatment options lead you to simultaneous compliance, and I will talk later about that. And eventually, if non-treatment doesn't work for you, you will be guided to treatment options. And before I jump on treatment, here are a few basics incorporated in treatment trees that I wanted to cover before we go with that. First, I want to say that trees are focused on best available technology, and that's because this is your safest choice. Safest choice because these are the most reliable alternatives that have already demonstrated full-scale efficiency in the field. And then it's important to understand that PFAS is not a traditional contaminant. So you really want to avoid backwashing here. And the only way to do that is to have pre-treatment to manage that fouling. Then think about competition. PFAS is PPT contaminant. So basically, everything in higher concentration is competing with the PFAS. So it can be TOC, it can be anions. All of this is affecting media lifetime, and PFAS is basically losing this battle because it's in very, very low concentration, which is 3-6 orders of magnitude lower. And then the next line is actually also about that. So it's trace contaminant. So it's not just that it's losing and, you know, all of this is affecting media lifetime, but PFAS can be pushed out by other competitors. And that's why you need lead leg. You need at least 2 vessels to manage these issues. But that brings you to that point when you have to have enough footprint. So this might be very specific site limitation that you have to have in mind. Then thinking about pilot testing, I want to say that jumping into pilot testing is not ideal approach. And that's because pilot testing is timely and costly, and there is potential for big mistakes. So it doesn't mean don't do pilot testing, but do these decision trees, do all of this prep before you go into that testing phase. And then eventually think about residual streams. If you know that you cannot afford some residual stream from some specific technology, then there is no need to consider that. There is no need to test for that. Let's see how all of that is organized in the decision tree. So first, we are going on general treatment selection, which purpose is to indicate potentially more suitable treatment alternatives based on general questions. Here is what it means. You are firstly asked about oxidation at the source, and that's because not all treatment technologies are compatible with oxidants. Based on your answer, potential issues will be identified and options to solve them will be addressed. So point of questions is not to stop you, but provide solutions. Provide solutions how you bypass issues that you have. So next question is about fouling. I mentioned this before. You don't want to backwash, but backwashing is for fouling. So how you manage this? Well, you think about what's your fouling potential. When we say fouling, you have to think about particulates, organic fouling, inorganic, and bacterial fouling. So it's a wide range of things that can foul your media. Then think about treatment goals. So, okay, it's PFAS, but are you targeting TOC here as well? Are you targeting any other anions or cations? Do you have any salinity issues? Eventually, what's your PFAS chain length? What are your corrosion concerns? And how much footprint you can afford for the treatment. Eventually, you will end up with one or more technologies, and you will be prompted to more specific analysis about them. If that's GAC, here is the decision tree. So again, we are running through the questions, but in a more specific way, specific for GAC. Your first question will be about fouling. Again, pre-treatment is key for PFAS treatment. So run this again, all of these, be sure what you have to deal with. Then think about nitrification potential. If you have ammonia in your source and you have GAC, you can get that nitrification issue. So you have to solve that. Then competition. And the major competitor here is TOC, but also all the other organic things. Focus here is on TOC because TOC is in ppm concentration. So it's really competing for that GAC. And here is very important message. 3 is asking if you have TOC more than 1 ppm. And people very often ask me, why 1 ppm? Well, this is because we know that competition will start to play here at this concentration, and that will affect media lifetime. So this concentration doesn't tell you stop here, you know, you have more than 1, you cannot use it. No, it actually says this will impact your media lifetime and eventually your cost analysis. So this is a red flag. Consider this because this will affect how much you pay every time you change your media. So finally, each tree leads to treatment evaluation. And this is because these trees are offering you preliminary screening, but you still need to get more specific about treatment performance. And you do that through treatment evaluation, through treatment testing. There is also simultaneous compliance to check. And it's basically telling you how this PFAS solution may affect other processes and rules. Here is ion exchange treatment tree. And again, it starts with fouling concerns. Then it's going to oxidant sensitivity. And this is because ion exchange is polymer-based media. So you don't want to have any kind of oxidant in contact with your ion exchange. If you do, this will degrade your ion exchange, but it will also make a byproduct, which is called nitrosamine. So be sure that you check for this. There are solutions provided here, but you have to avoid having any oxidant in contact with your ion exchange. When it comes to competition, now we are talking more about anions, so they are competing more here. With GAC, we had organics and TOC. Here we have anions such as nitrates and sulfates. So this ion exchange will remove more than PFAS. If you have nitrates and sulfates, it will remove them as well. The tricky thing is that nitrate and sulfates are in ppm level, and these ppm level are very high. So they can be, in sulfates case, in Arizona, we have few hundreds. So competition is very high. Again, competition affects media lifetime affects your cost. Like with previous three, when you check all of this, three will lead you to evaluate this treatment technology and eventually to go on simultaneous compliance. Finally, third best available technology is high pressure membranes, and here we have RO, and so reverse osmosis and nanofiltration. And while this approach should not be primary option for Arizona, it is important to say that there are situations where this is the only and best way. Examples for this application are usually complex water matrices with extreme salinity and multiple treatment goals. So specific for membranes is that pre-treatment is not a choice or part of optimization like what we had with GAC and anion exchange, but rather necessity because of potential for equipment failure. So first you have question about fouling. And again, all of these fouling categories. And then let's see, before I go on the next one, I want to say that fouling characterization is not only a matter of raw water here, but also recycled streams, because this is what you have with high recovery membrane processes. So with adsorption, you really think about fouling in your influent stream, in that raw water. But here, you also have to think about these for that stream that you are going to recycle to get that high efficiency recovery. So it's more into that. Then you will think about oxidant sensitivity, because polymers are again basis of these membranes. So you have to be sure that you protect membrane from degradation. So oxidant should not be in contact with any kind of polymer. Membrane has to be protected. Finally, there is a question about waste streams, and I have to say, if you did think about your system, if you analyze like those known things that we talked about, and you know that you don't have option for liquid waste stream with the PFAS, you shouldn't be even thinking about this option. So because the biggest issue with membranes is that waste stream. So we know that both RO and NF are good for PFAS removal, but if like this is a bottleneck, this waste stream, and if you want to manage that, and if you want to get as low as possible, you should probably be thinking and focusing on nanofiltration. In Arizona at the moment, I think that we don't have any nanofiltration system that is removing PFAS. I only heard about one system in Alaska, but I don't have any specific information about that. Again, after you run all of these questions, you will be directed to simultaneous compliance. And let me tell you now about simultaneous compliance 3. So here is official definition coming from EPA. What does it mean? But in other words, I would say simultaneous compliance means whatever you do for new contaminant, like for PFAS in this case, whatever change you do, whatever adjustment, you want to be sure that you don't mess up with the with the downstream processes and with other rules. You want to address PFAS, but not on the cost of any other regulation. And in this case, the simultaneous compliance tree is focusing on corrosion control and bacterial control. Corrosion control is very important here because any kind of change in source water or treatment requires you to do corrosion control evaluation, because all of these changes can affect corrosion. So you have to go and check what those impacts are. And then when it comes to bacterial control, it's really focused on treatment techniques, because whatever you do, you will have water stagnation with your filter. And then depending on the treatment technology, you can also have fines in your effluent. And those fines can carry bacteria. So you want to be sure that you have disinfection as the last step of your treatment range. Okay, here is simultaneous compliance tree. And you can see here that the difference is basically made between non-treatment and treatment alternatives. But both of them are leading to corrosion evaluation, because as I said, corrosion rule says if you have any kind of source change or treatment change, you have to go and check for this. And then eventually treatment will lead you to post-disinfection. And if you didn't have disinfection before in your system, you should also know that after adding one, you should go and check corrosion control evaluation. You should do that evaluation, because any kind of disinfection is changing oxidation potential of water. And with that different oxidation potential, they're concerned about corrosion. So I will now go and summarize key takeaways from decision trees. First, I would like to say that selection of best PFAS mitigation is utility specific. So there is many factors to consider here, and it's more than media lifetime. So if your neighbor has one type of treatment, don't think that that's your best option. It's okay to consider that, but this is really utility specific. Before you jump into treatment, consider non-treatment. That's your starting point. And that's really priority to be explored for small and disadvantaged systems, because that's the easiest way to address this. If you really have to do treatment, I have to say it's not easy to do it, but yes, you can achieve that. If I was asked about like one major thing that makes PFAS treatment different than any other treatment, I would say in this case, don't forget about pre-treatment. It's essential here, and it's probably required. I didn't see any PFAS treatment going without pre-treatment. So don't forget about that. Then when it comes to technology evaluation, it is critical for decision making. But don't run into that. Do all of these kind of analysis, known, unknowns, focus on your water quality parameters, run decision trees. All of that will help you to make that technology evaluation protocol. You really, when you come to that evaluation point, you want to know what to do and how to do that in an easiest way. You don't want to allow mistakes here, because They're costing time, they're costing money. Then collaboration. Collaboration is very important here. And I would say, I mean, there are 4 major parties when I say collaboration here. It doesn't mean it's limited to 4, but at least I see like 4 major ones. So you will have utility that has PFAS and seeking for solution. Utility will have engineer, and the sooner you get engineer, the better it is. Because the engineer is the one that is going to make this connection. Engineer will start working with vendor, getting their support, and then also before applying for anything, you know, from ADQ, that engineer definitely can come to us and, you know, clarify all kind of requirements, you know, get answers on all the questions. But we want to see clear expectations from utility, involvement of engineer, vendors and manufacturers are there to provide support. So use that. And then eventually what we are trying to do here as a regulator is to provide transparent expectations. Because if you know what you are looking for, it should be much easier for you to do that and for us also to permit your solution. Then examination is cheapest way. It's basically spend now to save later. Analyze what you need, what you have, what you want. Try to be specific. Think about your advantages, but also your limitations. The more you know, the easier it will be for you to make this decision. Don't forget about cost analysis. That's basically required for decision making. I know that most of these things that I was showing you was technical nature, but it's really techno-economical analysis that you have to do. You run all the technical things, but then you connect that with the cost, because that's the only way to make decisions. And then eventually you will come to us to permit your solutions. And that permitting can be straightforward. I really recommend you to follow recommended steps and communicate, you know, schedule pre-application meetings, call, ask, we are here to help. And now I would like to switch to support from ADQ. So this is beyond decision trees, but if you didn't do it already, please get your copy now. Here is a QR code. It's available on our website, and just yesterday we also published interactive version. So see what works better for you, either to go through all of these decision trees, or interactive version will ask you specific questions, and then based on your answer, it will lead you to another one. That's about decision trees, but there are other available resources. So all our trainings are available on YouTube page. And here is again a QR code to get you directly there. This training will also be available on the same place. And then I think that my colleagues talked about this before, but there is PFAS interactive map. So you can see the latest results through that. And hopefully this is not the end of support coming from ADQ. So our future plans are based on 3 groups of activities. We are working on guidance, documents, we offer pre-application meetings, and we do a lot of trainings. And this is the great opportunity to announce that our second PFAS forum is scheduled for February 13th, 2025. It's going to be in-person event in Phoenix, and I expect that ADQ announcement about this will come out soon. But we had one last year. It was February as well. It was a great success. So we are hoping to repeat that and provide all new updates with this upcoming one. But now, if you focus only on guidance documents, I would like to say that we are working on few of them, and they are all relying on decision trees, because decision trees is basically foundation. So we are working on testing protocols, on course tools, waste management, and point of use and point of entry guidance documents. If you have something else in mind or looking for collaboration, please let me know. But this is what is in process as of now. And as you already noticed through this presentation, ADQ support is primarily focused on best available technologies. And this is simply because best available technologies are the safest choice for small systems. These are the technologies that we have experience with that are used for years for other contaminants. Yes, things are more complicated now, but at least we know what we are dealing with. But this absolutely doesn't mean that ADQ prohibits any kind of innovations. It is only important for us to communicate that innovations might not be a best option for everybody. Because with BAT, we can simply say, you know, this is a straightforward process. But with innovations, you know, you will have many ups and downs, and maybe at the end of this road is better and greener solution. But, you know, I'm not sure, you have to know if you have what it takes. So you have to be sure that you have time to afford for that, because it will take longer to do design for innovations. Then it will cost you more. You know, you will have to do more research. You will have to do more testing, and eventually, when you permit that, you will have to train your staff. So it's very important that, you know, whatever you're planning to do, you have someone to run that. If it's innovative technology, you should count that you have to include that training for your staff as well. And then I have few slides basically just to provide a sneak peek to what is coming. I think we are good with the time. Yeah, so I will keep going here. This is some like what we are planning to do with testing protocols. So this slide is only about piloting, but basically testing protocols are supposed to give you guidance, you know, what to do before, during, and after that kind of testing. So it should start with decision trees, basically guiding you how you get results from decision trees, results such as, you know, what do you have to analyze, how you do media selection, so you narrow down what you want to test with this pilot testing, but you also see if you have to include pre-treatment in your testing. Then how to define hydraulics, because when it comes to pilot testing, you want to mimic your full scale. So you have to do that pre-analysis. You have to know what is empty bed contact time that you will have in your full system, but also hydraulic loading rate. You define that, and then based on that, your plan for full scale, you come back and you apply that to pilot. That's the only way to get meaningful results. Then we'll provide guidance how to calculate pilot duration. You don't want to start something that you don't know how long it's going to last. You have options here to use your water quality parameters and to do model yourself, or contact vendor to help you with the model estimate, so you can see when to expect breakthrough. then eventually, when you install that pilot, you want to be sure that you have sampling force. Because if you don't, you are only looking for 100% breakthrough. So you're really blind here, and that blind can last for even 2 years before you get breakthrough. So what we really suggest is to put sampling force on 25% increments, and then this way you can also allow yourself to do so-called accelerated pilot testing, which means if you get a breakthrough at 25% and then you combine that with modeling, you can get projections what will happen with that 100%. And the really point here is that it's savings, time, cost, and everything else. We don't really want to see you running pilot testing for 2 years. If there is a potential to do that in 6 months, we are absolutely open to that, and it seems that this is the way to do that. Then we'll guide you how to prepare monitoring plan. Monitoring plan is PFAS, but also interference sampling, because you will have some outliers. You want to understand why you have those. You want to know what push for those results. So it is common to do bi-weekly sampling at 25% force. I said you want PFAS and interferences, but you want influent and you want effluent. And probably the most important is you have to align this with budget. You don't want to burn your budget in the first month and have like PFAS non-detect. So it's very important to do planning here. And then I mentioned also before, think about modeling. Modeling can short pilot duration. And I think that my next slide is about modeling. So we also plan to provide guidance here to say what models are available, you know, how you access them. They're free of charge. And as far as I know, EPA is also providing support on how to run these models. But you have to be very specific here. You know, you have to know what's the purpose of the model and how to use it on what stage. The most common mistake is that people think that model can replace testing. No, it cannot. Model can supplement testing, and that's a great combo. But don't think that you can only go and do model yourself, because all the models are about calibration. So you have to put the test data, good test data, which is beyond water quality parameters, in order to get reliable model predictions. So it really comes to you, it comes to your interpretation, but model and testing, pilot testing, when combined, I would say that's a great example of collaboration. Then I mentioned before, the other guidance document that we are working on is point of use, point of entry. And that's the document that should come out soon. I would say, if I have to guess, I would say next 3 months. At least that's my plan. This document is going to be structured in form of frequently asked questions. And the reason for that is basically, you know, like none of us have time. So if you have specific questions, you should be able to jump between those questions and get specific answers. This document is going to cover more than PFAS, but it is very important to know that at the moment, point of use and point of entry devices are not recognized as a compliance option for PFAS. And this is not connected with ADQ. This is not like our standpoint. This is basically because there is no NSF certification at the moment that is aligned with the MCL. So what you have on the market is units that are certified for PFAS for the effluent of minimum 20 ppt, and that's 5 times more MCL. we expect that this is going to be solved soon. I know that NSF is working on that, but until then, you can use this for your household, but it cannot be approved as a compliance option. This document also includes examples. So this first one is showing how to search to NSF database. And then the second one is basically pointing out what to look for what information to look for in that database. Like this is what you will get through this NSF website, but this is not going to be enough. That's why it is important to find a claim for that specific unit and model. And this is example of one claim. And we will also explain how to read the claim. And then, this is example of common mistakes. I would say people think when there is an NSF stamp, that's it, that's what you're looking for. No, it's more into that. So there are many NSF certifications, there are many different claims. So we will try to guide you here and explain meaning of, small letters next to this NSF stamp. But the key point is you want to get the claim. You want to get specific information in order to see what a unit is certified for. And this is the end of my presentation. Thank you for your attention. I think that now it's our time for questions. We are 7 minutes early, but yeah.
That is quite all right. Thank you so much, Yasmina. Thank you for the presentation. As Yasmina mentioned, we do have some time for questions. You can take this opportunity to ask any of our presenters any questions that you do have. Take advantage of having these experts here and available if you'd like to drop some questions. And as a reminder, while you're typing some questions in there, all of these presentations, the slides are available for download, whether you're in the handouts section in the GoToWebinar panel. You can download the agenda and all of the presentations and the decision trees from there. Those will also be emailed out later through a share file where you can download all of those presentations as well. And we will have this whole webinar posted up on our ADEQ YouTube channel in the coming days, so you can keep an eye out for that if you'd like to revisit any specifics. I do see one question here so far. Is MAP doing PFAS sampling? Whichever presenter wants to hop in and help me out. Thank you, Sarah.
This is Sarah. I can try and answer that. That is something that we're still looking at and determining. The PFAS sampling is quite expensive, so we're just looking at the budgeting aspects to see if it can be included.
Excellent. Yeah, we will keep you posted on that. Another question. Looking at our lab reports for UCMR5, there's no mention of version 1 or 2 for method 53.7.1. How can we tell if the data qualifies?
Yeah, I can answer that. That would be a question you would have to direct towards the laboratory. You can email them or call them and have them send you the certificate of accreditation for that method, and then they should specify whether it's version 1 or version 2. Hope that answers your question.
Yeah, thank you, Gavin. If you have any follow-up questions, feel free to drop them. Ted, I'm sure you're not the only one. Sometimes the handout section is missing. So if you're not seeing the handout section, but you do need a copy of the agenda, feel free to leave us your email or shoot us an email. I have the OpCert email up here on the screen now. You can email that and we will send you a copy of the agenda. Another question, is there any guidance for wastewater / reclaim PFAS sampling from ADEQ yet?
I'm not aware of any. Yeah, so we are drinking water section. As of now, any kind of reclaim is not allowed to be drinking water source. Yeah, so I cannot really speak about that, but not based on my knowledge.
Perfect. OPSERT question, 30 PDHs need each 3-year cycle to renew OPSERT. 30 PDHs are the requirement for renewals. If you have multiple certifications that have the same window and you collect 30 PDHs that fit for the certification periods for multiple certificates, you can use the same 30 PDHs for all of your certificates for renewal. If their periods do not overlap, you might end up needing 30 for several certificates, but 30 is the minimum for renewal. You may, as I said, end up needing more depending on when the PDHs are required. But just take a look at your certificates start and end periods and make sure that the 30 PDHs were collected between those 2 dates for whatever certificate you're trying to renew. Another question, will PFAS treatment impact AWP systems?
So this is all going to be connected. AWP rulemaking is in process. I believe that they covered PFAS issue. Eventually, regardless of source, drinking water will have to meet MCL standards. So I don't know details, but it's possible that this can be addressed either on AWP side or on maybe existing drinking water utility side. But eventually, regardless of source, AWP or not, drinking water will have to meet federal standards.
Excellent. Thank you, Yasmina. I will leave the webinar open here for a couple more minutes. Please feel free to keep asking questions if you have any. But at this point, if you have no more questions, you are welcome to leave. Feel free to make sure you grab that agenda if you need it. Here is another question. Just to clarify, sampling is best after treatment and storage and before points of distribution.
Yes, that's correct. Yeah, you want the finished water, so after any storage, treatment, anything like that, but before distribution.
Perfect. Awesome. Thank you so much, everyone, for attending. Once again, a couple more minutes if you do have more questions, but thank you for being here. The webinar will be up online soon. You can check out whatever you need to once again, as well as finding in the agenda those contacts for any of our presenters today, should you think of any other follow-up questions going forth. Thank you to all of our presenters as well. Appreciate you guys. I will go ahead and close the webinar here. Hope everyone has an awesome weekend and a good rest of your day. Oh, one more question just popped in. Where is the renewal fee schedule? Is that for OPSERT? If you check out the ADEQ OPSERT page, on our ADEQ website, there's a section for OPSERT. We have a section for all of our current fees. I can find for you the current renewal fee in just 1 second. I don't have it at the very top of my head. The current renewal fee is $210 for a certificate, but if you're renewing multiple at a time, it's $210 for the first renewal and $70 for each additional renewal certificate renewed at the same time. Excellent. I will close the webinar here. Thanks again, everyone.